Okay, so we just finished 2.4 exact equations, So we started from separate equations in 2.2, and then we did linear first order differential equations, and then we did exact equations. So all the topics are for first order differential equation. Okay, and there's several other cases that we can solve the first order differential equations, and we have different schemes to solve in each case. So this whole chapter is about the first order differential equations, and we have different problems, and we have to use different strategies to solve the equations. And still, there are a lot of problems that we cannot solve, even though we have so many methods. Okay. So you can see how hard it is to solve different equations. And this is just for first order differential equation. It becomes more complicated when we try to do a higher order differential equation. Okay. So in 2.5, we're going to talk about solutions by substitution. That's not the method to solve differential equations. And this is the last section for this chapter. And in different situations, we have different types of substitution. All right. So there's no general rule, how to substitute. No. You have to use different schemes to different problems, again, even for substitution itself. So we're going to start from homogeneous equation, and then we're going to talk about two other types of equations that we can use substitution. So homogeneous equations is one type of equations that we can use substitution to solve the problem. Okay. So what is a homogeneous equation? We start from the definition of homogeneous function. Okay, so what is a homogeneous function? So suppose we have a function f is a function of two variables x and y. So if you just multiply the variables, both x and y, by a factor t, and plug into the function, then if you get the new function equal to t to the alpha times f of xy. So if f of tx, ty equals t to the alpha times f of xy. Okay. And then we say this function is homogeneous. It essentially means you have the same order powers of x and y. You only have those terms with x and y in this function. Okay. So that if you rescale x and y at the same time, it becomes some factor times the original function. All right. And this number alpha is a real number, and it's called the degree of the function. All right. So for example, if a function f is x cubed plus y cubed, then when you plug in tx for x and ty for y, it becomes tx cubed plus ty cubed. So then you get the t cubed x cubed plus t cubed y cubed. Then you can factor out t cubed from the two terms. So that it becomes t cubed times x cubed plus y cubed. And that's just t cubed times f of xy. So you can see this homogeneous function with degree 3. Okay. So if you look at the original function, you can see both the x and y have power 3. So that tells what types of functions a homogeneous function is, right? Okay. So then with the homogeneous functions, we can define a homogeneous differential equation. Okay. Again, we write differential equation in the differential form. Okay, so suppose we have a differential equation m of xy dx plus n of xy dy equal to 0. Okay, so I forgot to put equal to 0 in here. So, so this is differential equation in the differential form. So this equation is homogeneous if both m and n are homogeneous of the same degree. Okay. So that means m of tx dy equals t to the alpha m of xy and n of tx dy equals n to the alpha times n of xy. Okay, so this function m and n in the differential equation, they have to be homogeneous and with the same degree. Then we call this differential equation a homogeneous equation. All right. Okay, for those types of equations, we have a special scheme or strategy for substitution. Namely, we use substitution y equal to x times u, or x equal to yv, it doesn't matter which way you do, both will work. So you change the variable by letting y equal to xu or x equal to y times v. So what it means here is you just define another variable u. Okay. Okay, remember, we're trying to solve this differential equation. So we want to know, the solution y as a function of x. So y is a function of x. So when you write y equal to x times u, that means u is also a function of x. If you divide by x on both sides, you're going to get u equal to y over x. So u is a function of x, actually. It's not a constant. Similarly, you can write, v equals x over y. So again, v is a function of x also. Okay. And in that way, we can rewrite the original differential equation in terms of u and x. When you replace y by x times u, you don't have y anymore in the equation. Instead, you have x and u, and you try to solve u as a function of x in the new equation. Or if you use x equal to y times v, then the new equation will not have x. Instead, it only has y and v as variables. and you try to solve v as a function of y, okay? So that's the idea. So let's do one example. Suppose the differential equation we have is x squared plus y squared dx plus x squared minus xy dy equal to 0. So first, identify this equation as homogeneous equation. You can see x squared, y squared, xy, you know. If we use the definition of homogeneous equations, you know, all of those terms are homogeneous with degree 2. If you replace x by tx and y by ty, you know, you just get t squared in each term. So it's a differential equation with homogeneous functions of degree 2. So that's homogeneous differential equation, and we can use the scheme y equal to xu or x equal to yv to solve this equation, okay? So let's just use the first substitution, y equal to xu. All right. So that means u equal to y over x if you divide by x on both sides. Now, what you do is, you know, you write dy, okay. I think there's a typo here. It should be dy. If you try to find the differential y, then you have to use x times u and do the product rule. Remember? So that will be x du plus u dx. So remember, the differential of a function is the derivative times dx. Okay. If you do that, you have to use the product rule for x times u because x and u both are functions of x. So you use the product rule to find derivative and then times dx. And then you can rewrite everything in terms of differentials, okay? And what it gives is just x du times u dx. Okay, so you can check yourself at home or double check it. So we know y is a function of x and u is also a function of x in this case. So then you just replace dy by x du plus u dx, okay? And then y by x times u. So we're gonna get x squared plus x squared u squared. Remember, y squared is just the x squared times u squared times dx plus x squared minus x times xu, which is y. So then x times u is just x squared times u. Okay. So remember, you have to substitute everything, you know, in this equation, each term, including the differential. So the dy is just the x du plus u dx. So you can see the new differential equation only has variables x and the u. And you try to solve u as a function of x. Okay. So this becomes a new differential equation. So you can see you got x squared in each term. Okay, that can be canceled. So that's the whole point of homogeneous equation, why we can use substitution, because x squared will be canceled. Okay, so then the equation becomes 1 plus u squared if you cancel x squared. And here, you just get 1 plus u squared times dx plus 1 times u. You know, you have to cancel x squared here and here. So 1 minus u times x du plus u dx equals 0. So that's the equation after simplification. And then you just distribute the 1 minus u, you know, to x du and u dx, so that you get 1 minus u times x times du plus 1 minus u times u dx. Okay. Now you can combine the first term, 1 plus u squared dx, and the third term, 1 minus u times u dx, because they both have dx in here. But before that, you need to distribute u into 1 minus u in the last term. So that becomes u minus u squared if you do that. Okay. So now you can combine the first term and third term. You can see negative u squared and u squared cancel. They both have dx to multiply. So what is left? There's just 1 plus u dx. Okay. And then the second term is still 1 minus ux du equal to 0. Okay, so that's the new equation after all the steps. Now, what is good is we can solve it by separating variables. So you can separate x to u in this equation and solve it. Okay. So if you move 1 minus u x du to the right side and change the sign, then it just becomes u minus 1 x du. Okay. You have to negative 1 minus u. Then you get u minus 1. All right. So now what you do is divide by what? By 1 plus u and x on both sides. Okay. So if you divide by 1 plus u or u plus 1, then the left side just has dx, but then you divide by x. So you get dx over x. On the right side, you divide by 1 plus u. So you get the 1 minus u over u plus 1. And then divide by x. So that cancels. So then you get du. So you can see we just separate the variable. Okay. Right? Remember? Then we can integrate on both sides to solve the equation. So then the next steps are just some details of how to integrate the right-hand side. We know how to integrate the left-hand side. For the right-hand side, we can rewrite the u minus 1 over u plus 1 as 1 minus 2 over u plus 1 if you just rewrite the u minus 1 as u plus 1 minus 2. Then you break the numerator into two terms, u plus 1 and the negative 2. And then you get two fractions. So u plus 1 over u plus 1 is just 1. So that's why you get 1 minus 2 over u plus 1 on the right side. And then you just integrate. Now, you're going to get the natural log on both sides. So actually, you're going to get the natural log of absolute x when you integrate on the left. And on the right side, you get the u when you integrate 1. Remember, you are integrated with respect to u. Okay, so that's u. And you get 2 times natural log of u plus 1, absolute u plus 1, because again, you get the u plus 1 in the denominator. That will end up with natural log. Okay. And you got 2 in the front, that's the coefficient, plus c. Okay. So now then the next thing is just to rewrite this solution, by y and x, because we're trying to solve y as a function of x, and the u is just the variable we defined, and it is y over x. So just replace u as y over x in each term on the right side. Okay, and then do a little simplification with the natural logs. So you can move the term of natural log on the right to the left, so that becomes positive. So we got natural log of absolute x plus 2 times natural log of absolute y over x plus 1 plus y over x plus c. Okay, so then you just do it step by step to simplify this equation a little bit. So you can put the 2 in the front, the natural log as the exponent in the natural log. So the second term on the left is just the natural log of y over x plus 1 squared. Okay, that's the property of natural log. And then you got a sum of 2 natural logs that can be combined. So what you have now is just the natural log of absolute x times y over x plus 1 squared. Okay, if you do that, well, you can also combine y over x plus 1 by using the least common denominator x. You can write 1 as x over x, so that you can combine y over x and 1 to get x plus y over x. Okay. So just be careful on each step when you try to simplify the expression. So that becomes x plus y over x squared in here. Then, if you square this fraction, you're gonna get x plus y squared over x squared, and that will cancel one of the x in the front. So you're gonna just left one x in the denominator. When you do that, so that becomes natural log of absolute x plus y squared over x on the left side. Okay, now you can take the exponential on both sides with the base e, so that you just get x plus y squared over x with the absolute value sign. Okay, and the e to the x plus y, e to the y over x plus c. Or you can rewrite that as e to the c times e to the y over x. Remember, when you have a sum in the exponent, that becomes the product of exponentials. Okay. So now e to the c is just a number. So we can rewrite this equation as x plus y squared over x equals c prime times e to the y over x. If you consider, e to the c is just another arbitrary constant, and you get rid of this absolute sign by introducing this arbitrary constant, c prime, which can be both positive or negative. Okay, so that takes care of the absolute sign. Okay, all right. So at the end, you multiply x on both sides, you're gonna get x plus y squared equal to c prime x times e to the y over x. Okay. So that's the final answer for the problem. You can see it involves quite some steps, and it's not straightforward. We have to do substitution y equal to xu and solve for u from the new differential equation. And then we need to come back to the original function y and do a little simplification of the answer, So it's a little tedious. And you have to be familiar with the properties of exponents, natural logs, and those things quite a bit. Differentials. And you have to use some other techniques to solve the new differential equation. Namely, in this case, it's just a separable equations. Yes.
I can't see you're covering all the steps.
Can you see now?
Oh, I see.
Yeah. Yeah, this is just one example. It takes quite a bit of time and effort to do it. And it's easy to make mistakes when you try to solve this equation. But that's the way it is. You cannot find an easy way to do it. Does anybody have any questions for this example?
When you said earlier there was like different ways to do it, or it's just one way to do it?
That's the way to do it. I don't think there's any other way that we can solve this equation.
What would this be used for? Like what situation would need you to?
There are, I don't know if there's a specific example in reality, in real problems. They might, you might get some equation like this, in real problems. That's possible. I don't know exactly what kind of problems it will be, but we just try to solve any types of differential equation mathematically, so that when we do have this kind of problems, then we can solve it. So in mathematics, you want to solve everything you can, right? So any other questions? Yeah, just try to go through the whole example step by step and try to work out every details for this problem if you are not quite sure. Because, as you can see, there's a lot of work in just one problem. And I didn't write down all the detailed steps because we don't have so much space. Wait. Does anybody have any other questions from the audience? If not, I guess I will stop here.